This is John Courier with the Equipment and Coatings Technologies, 50 years in the spray foam and coatings and polyurea coatings industry. And today we're going to talk about the different types of pumps. And so I'm going to go through these few pumps and give you a better idea of the way I see these pumps. The types of pumps in the spray foam and polyurea coating industry, 1 to 2 and 25. Hydraulic reciprocating pumps. These pumps are use independent hydraulic reciprocating with a mechanical trip rod for directional change. And I'm going to explain that and show you a little better earlier, ensuring precise ratio control. This setup is known as an independent hydraulic reciprocating drive system, which provides better ratio control and minimizes the pressure loss during the changes. These pumps are ideal for high pressure applications and are commonly used in spray foam and polyurea coatings. A total of 4 pumps are maintained: A and B pumps, hydraulic pump, pump loop peristaltic pump, and common drive hydraulic pumps. Now, common drive, they are not known for fast pump changeover, with several electrical components, switches and solenoids, and all of the above that can lead to pressure loss and directional changes. Common drive systems are typically used for applications requiring a fixed 1-to-1 ratio, but can be challenging to maintain precise control with 2 different components. Note, these chemicals are different in viscosity and different in coefficient of friction and flow and temperatures, and use central directional common drive control pump. This system uses a 4-pump setup on the pump line with 2 fluid pumps, one for iso and one for resin, also the iso pump lubricating side, and the directional control pump. Some are incorporating a peristaltic pump, loop pump. This is 4 pumps with the transfer pumps equals up to 6 pumps, and finally the main hydraulic piston pressure pump, compensating pump, making a grand total of 7 pumps. Okay, and then we come down to pneumatic pumps. Driven pumps, they're pneumatic pumps use an air motor to drive the chemical pumps. They are similar but not cost effective due to the need for large air compressors and air dryer systems, which increase the maintenance costs and the operational costs. Pneumatic pumps are suitable for low pressure applications, or often used in large plants with existing air and filter systems. It could be using an existing system. Okay, electric pumps are type A. These pumps are used in electric motor drive, the chemical pumps with gears and a connecting rod like a locomotive. This system is one motor operating a common drive on each end of the motor. Typically, common drive pumps with shorter strokes and faster changeover times can lead to issues with maintaining the correct ratio, especially with the varying viscosities, coefficients of friction, flow, and temperatures of the A and B components. Electric pumps are not suitable for a wide range of applications and could result in off-ratio pumping, leading to inefficiencies and increased material usage. Total of 5 pumps to maintain. Now, electric pumps type B, they are the electric stepper motors or frequency drive motors that are connected to small gear pumps driven by these electric motors. These systems have no siphoning capabilities, so also rely on drum transfer pumps. Other problems include they cannot pressure compensate, like hydraulic can start and stop under pressure. Therefore, they have to be electronically controlled on and off so that the gear pumps will not blow their seals with spray pressures when stopped. These gear pumps also have tried to move the higher viscosity polyureas, chemicals not recommended for thicker component coatings. Now a 4-pump system, advantages of hydraulic reciprocating, independent drive pumps, simplicity. The CDS proportioner is designed to simplify with a fewer components and straightforward operation. This reduces the chances of mechanical failures and makes maintenance easier. No transfer pumps. These pumps do not require transfer pumps, which simplifies the setup and reduces the overall cost. Single preheaters. Only one preheater is needed for both sides, which saves energy and reduces the complexity of the heat. Mechanical operation. The pumps operate mechanically without the need for directional change components, which enhances reliability and reduces maintenance. Low power consumption. These pumps require the least amount of wattage to operate, typically under 40 amps, making them energy efficient. Easy troubleshooting. The simplicity of a system allows for easy troubleshooting and independent testing of the components. Simply get parts locally across the United States. No PLC system needed. The system can operate without a programmable logic controller. PLC, which further simplifies the operation and reduces costs. Full heat control system provides full heat control from the drums to the gun, ensuring consistent material temperature and quality. Simple, small, space footprint in the rigs. Pumps can be mounted on the walls. Battery operation. These pumps can operate on batteries, making this versatile and suitable for remote or off-grid applications. Environmental benefits. The system does not use CO2 or ozone-depleting substances, making it environmentally friendly. Cost savings by reducing the complexity and energy requirements. These pumps can save thousands of dollars in expenses and fuel. Independent reciprocating drive systems. Improved ratio control and better ratio control, allowing for precise adjustments even with off-ratio spraying. This is partially beneficial when dealing with varying viscosities, coefficient of friction, and flow temperatures of the A and B components. Isolated pressure control. Each component is driven independently, so restriction or blockage in one component does not affect the pressure of the other. This isolation simplifies troubleshooting and ensures consistent spray patterns, enhancing troubleshooting. Independent drive systems make it easier to identify and address issues as each component can be tested separately. This reduces downtime and improves overall efficiency. Temperature management. Excuse me 1 second here. I gotta get rid of my... Okay, I'm back. This system works efficiently. Temporary management, proper heating, and insulating both components from the drum to the spray gun is essential for maintaining the correct viscosity and ensuring optimal spray performance. Additional considerations: viscosity differences. The statement correctly highlights the importance of managing the viscosity coefficient of flow difference and temperature curve between the A iso and B resin components. This is crucial in trying to match the flowability of the A to B ratio or ratio needed. And needed training and operating expertise is needed, requires a higher level of technical knowledge, and proper training is essential to ensure that operators can effectively manage the systems and achieve the desired results. Environmental impact. Independent drive systems can contribute to more efficient, environmentally friendly operation by reducing the need for large generators and minimizing CO2 emissions. Applications: hydraulic reciprocating independent drive pumps are ideal for high pressure applications, including protective coatings, industrial equipment, bridges, ships, and tanks. Insulation spray foam, insulation for buildings and homes and ships, freezers and homes, excuse me, automotive parts, coatings for automotive parts to protect against corrosion and wear. Construction materials, back hopefully doing better now. Construction materials, it's insulation for buildings, concrete and steel to enhance durability. Durability: hydraulic reciprocating pumps are known for their durability and reliability, making them suitable for demanding applications. Hydraulic reciprocating pump unit has its own mechanical directional change incorporated in the pump, proportioning two pumps connected with a common drive direction. Controlled hydraulic unit equates to a 4-pump system. Usually need transfer 2 pumps with a pump lube and a main hydraulic pump. Become a 7-pump system to maintain. Spray gun, where the polyol and the isocyanate are mixed just before the exiting of the tip. Spray gun, hydraulic reciprocating pump system. Okay, now here's what I want to do here. I want to stop that there, and I'm going to come down here and I'm going to show you. This is a hydraulic reciprocating. This is a clear hydraulic reciprocating pump over here, and you can see that everything happens. There's nothing for a directional control valve, and here's the pump. There's the control valve right down here at the end. You can see it with my deal just a little bit fluttering back and forth, and 2 check balls in the system. Okay, and this is a pressure compensating of a variable piston pump. For pressure compensating, they're a piston type pump where you can adjust the pressure for spray. And in contrast, here's a cutaway of a hydraulic reciprocating pump. Hydraulic variable piston pump. Okay. Here's your ISO pump, your loop pump, your directional control pump with all the directional control wires, your connection, and your resin pump. Plus in the back you've got your main motor and a hydraulic pump to run the hydraulic oil through all of that. Plus on top of that you have a total of 7 pumps to maintain, plus all the directional pump control circuits. I'm John Currier. My web is www.ectech.com. Email to johnpc@comcast.net. Cell is 206-979-3533. And don't forget to sign up for my podcast. Now, I'm going to stop here and I'm going to try to do one other little deal. Please hold. Okay, I am back. And now I want to show you how this pump really works. You can see it operating. It's a mechanically directional change. It's so fast, no electrical system, none of all these other stuff. It's a separate, most efficient directional pump. And then thank you again.